In 2026 alone, Alphabet, Amazon, Microsoft, and Meta committed $725 billion in capital expenditure to build out physical artificial intelligence infrastructure. To put that capital in perspective, that single-year commitment roughly equals the entire gross domestic product of Sweden. The initial wave of this technology focused almost entirely on training conversational chatbots that operated inside virtual environments. Deploying what the industry now calls agentic AI, systems that autonomously act, reason, and operate, requires a sustained density of physical computing power that simply did not exist a few years ago. This image from Morgan Stanley outlines the taxonomy of this new economy. It divides the landscape into three distinct tiers: the technology itself, the enablers, and the adopters. Mapping these tiers is how we determine who ultimately captures the profit. The foundation of this system belongs to the enablers. These are the companies pouring concrete, manufacturing silicon, and laying the heavy grid infrastructure. Hardware bottlenecks are currently being addressed by systems like NVIDIA's Vera Rubin platform, particularly the NVL72 rack-scale supercomputers, designed for massive training and inference workloads. But this extreme physical density creates an immediate ceiling. Pushing that much data through processors generates massive heat, requiring liquid cooling and drawing immense amounts of electricity. In the United States, data center power demand is now projected to double by 2027, creating a severe shortfall on the national power grid. The shortage is so acute that technology companies are now securing data center leases by paying premiums of up to 300%, strictly to guarantee they have access to the power supply. The enablers are capturing the initial wave of capital, but their long-term growth is strictly capped by the hard limits of real-world land, cooling, and electricity. Moving up the supply chain, we reach the infrastructure tier. This is dominated by the hyperscalers and specialized AI-first neoclouds who own and operate the data centers. These operators use their scale to create structural lock-in. Amazon, for example, made a $25 billion commitment to Anthropic, ensuring those models are integrated directly into Amazon's proprietary governance tooling. These multi-decade compute contracts provide the massive capital required to train natively multimodal software, like Meta's Llama 4 and Google DeepMind's Genie 3. The goal is to support agentic AI. Instead of just answering text prompts, these models are designed to execute complex, multi-step digital tasks without human intervention. Because the physical infrastructure is so expensive to build and maintain, the rest of the global economy is effectively forced to operate within these closed, proprietary computing environments. That brings us to the top tier, the adopters. These are the traditional enterprises renting this compute power to deploy intelligent systems into the real world. Using platforms like Microsoft Copilot Studio, organizations are deploying agents equipped with computer use, allowing the software to independently navigate legacy interfaces that lack modern APIs. Across the United States, enterprises are reporting a 30% reduction in operational friction by shifting to this multi-agent orchestration. In the public sector, pilot programs integrating AI into Pakistan's healthcare system have already generated a 15 to 20% increase in fraud detection efficiency. Meanwhile, heavy industry and financial institutions are utilizing alternative credit scoring models to parse vast amounts of unstructured data and predict risk with high accuracy. The adopter tier is where the entire infrastructure build-out is realized. They convert raw, expensive compute power into permanent economic efficiency. Building at this speed introduces macroeconomic risks, particularly the rapid influx of unregulated shadow financing. The Bank for International Settlements has formally flagged the use of off-balance sheet special purpose vehicles, which tech giants are using alongside private credit funds to silently finance these data centers. Geopolitically, nations are increasingly treating AI infrastructure as strategic national security assets, driving localized, sovereign compute contracts that keep data strictly within domestic borders. When the $725 billion of capital expenditure settles, the critical question is who actually captures the resulting profit over the next decade. This chart projects ROI across sectors, illustrating the flattening profit margins of hardware enablers versus the compounding upward trajectory of enterprise adopters. Approximately 80% of economic benefits will come from cost efficiency, represented by a 310 basis point margin expansion for adopters. The financial data indicates the enduring wealth generated by this build-out will not accumulate in Silicon Valley hardware laboratories, but on the balance sheets of traditional, real-world enterprises that successfully automate their operations.